So today we're going over factoring. This is lesson 4.4. Always take out the GCF first. So that's just always a good idea. If you have something like 4x plus 6, you would take out the GCF, which is 2. That would be 2x plus 3 times 2. Right, so that's part of the factoring. It's just a GCF. You keep it there, but always take out the GCF. It'll make everything easier. It'll make your life easier taking out the GCF. That leading coefficient, which means should always be positive. So that was 4x. That would be okay. But if you had a negative there, you want to take out a negative. Even if that's just take out -1, you always want that leading coefficient to be positive. It'd be very difficult to factor something like this. And so, like if you had something like that, take out the negative first. So now it's plus 5x. Now it's -6. And then you should be able to factor something like that relatively easily. We'll get into that in just a minute. So can you factor this? So just try this one, go ahead and stop it and try to factor that. And so if I'm going to factor this, I'm going to do 2 steps in one. I'm going to both make sure that leading coefficient is positive and take out a GCF. So I'm going to take out a negative. If I look at just the numbers, 7, 14, and 21, I can take out a 7. If I just look at the x's, I have x to the fourth, x to the first, x to the first. I can take out 1x because that's what's in common to all of them. It's a common factor. Y squared, y to the third, y to the fourth. There's at least 2 y's in everything, so y squared. So this would be x to the third, just x to the third, right? I took out a negative, so I'm going to make that a minus sign now. 7 times 2 is 14. Y to the first. Took out a negative, so that's now a minus sign. 3 y squared. And what's inside there doesn't really get factored anymore, so that I can think of. So you're pretty much done factoring. So if you do find a GCF for all the terms, that is considered factoring. Although sometimes there'll be additional factoring here after you take out a GCF. Like here, I took out a negative. There's still additional factoring that can be done on that problem. So here's when the leading coefficient is 1. What I mean by that is it's just plain old x squared, right? 1x squared. It's just that first coefficient is 1. We call that second coefficient of x b, and the constant we call c. And so this is something you've probably done before. So if you do something like this, you're going to factor. I don't know how you used to do it, but I usually start with x and x. Sometimes you know something about the sign, so numbers that multiply to make a -6 and add to make 5 there, to make that middle term. So if 2 numbers multiply to make a negative, one of them is positive, and one of them would have to be negative, if that makes sense. And so you can think through all the different possibilities, like you might think maybe it could be 2 and 3, maybe it could be 6 and 1, or some combination of those two. Like it might be a different order, but that's what it could be. So you could try these. Like you kind of use a pencil with eraser, you can kind of guess and check it and think. And what you're really doing there is you're looking at inside outside. So you're looking at if I multiply the inside and outside and add them together, do they add up to make 5? And in this case, with 2 and 3, that'd be 2 plus -3. 2 and 3 clearly don't add up to 5 when one of them is positive, one of them is negative. So I'm not too excited about that possibility, but 6 and 1 do add up to 5 if one of them, the bigger number would have to be positive. So I think this actually works. So if you double checked it here, you go 6x plus -1x is 5x, 6 times -1 is -6, x times x is x squared. That's definitely the factoring of that quadratic, and you're done. So I think it helps again to pay attention to the signs when you do this. So let's try this one. Again, I think you've probably done some of this factoring before. So if you're going to factor this, you start with x and x. Plus and plus, so you know this is plus. And then you're thinking of different possibilities. That's a really bad parentheses right there. You're thinking of different possibilities for like 12 and 1. 6 and 2, but those don't add up to 7. But I do like 3 and 4 as a possibility. So I don't think it really matters the order since they're both plus here. So just double check it. You're looking again inside, outside. Do they add up to make 7? 3x plus 4x is 7x. 3 times 4 is 12. That definitely works. Think about the signs here. So you start with x and x. One of them's positive, one of them's negative because it multiplies to make a negative 15. I can just think of 5 and 3 that 15 and 1, I guess, but 5 and 3 could add up to 2. The bigger number has to be positive because 2 is positive, and the smaller number would have to be negative. Double check it. 5x minus 3x is 2x. 5 times negative 3 is negative 15. We've got it. And last one of this type. So start factoring x and x. This is positive, but the middle term's negative, which means positive means they're both the same sign. Since the middle term is negative, this must be negative. 4 and 2 doesn't add up to 9, but 8 and 1 would add up to 9 if you double check it. 8x minus 1x is negative 9x. Negative 8 times negative 1 is positive 8. That one works. So difference of squares, I know you've seen this before. This is a formula you use to factor. This fits the form of difference of squares. If you don't see it, like that's the form of different squares. 25 is a perfect square. 5 times 5 is 25. You could rewrite this. If this is easier for you to think about it this way, like that's the same thing, right? And now it's in the form we need. A is obviously equal to x, and b is equal to 5 there. So the factoring of this would just be a plus b, a minus b. So it'd be x and x are your a terms, 5 and 5 are your b terms, and one of these is a plus and one of these is a minus. And you've probably seen this before. You'll get very familiar with this throughout Algebra 2. Again, so it's maybe easy for you to see, maybe not, but x squared is a perfect square, 4 is a perfect square, and y squared is a perfect square. So I know that the first term is going to be x. It fits the form of difference of squares. There's a minus sign in between. So one of these is plus and one of these is minus. Doesn't matter which one. The square root of 4y squared is 2y. So, and you could double check it if you need to. Positive 2xy minus 2xy is 0. 2y times negative 2y is negative 4y squared. X times x squared, you've got it. So try this one. And the problem with this one, it doesn't seem to fit the form. If you notice, we're always looking for perfect squares there. 18 is not a perfect square. 50 is not a perfect square. So you might go, well, it doesn't fit the form. I think we're done here. I don't think I can factor that. But remember the first rule of factoring. Remember I said that the first thing to do to make your life easier is take out the GCF. So there is a GCF there. It looks to be 2 times 9x squared minus 25. They're both even numbers, so I can take out a 2. Now this should factor further, right? So 2 times, that does look like difference of squares. So 3x and 3x squared root of 25 is 5. 5, and one of these is going to be a plus and one of these is minus because it fits the form of difference of squares. After you see this one, stop it, try to write your answer as fast as you can. What is this might be too easy though, what's the factoring of x squared plus 9? So try to factor that real quick, and you might notice it doesn't factor. So this is does not factor, DNF. You might try to factor it. You say, well, maybe x plus 3 times x plus 3 works, right? That'd be very tempting. But 3x plus 3x is 6x. There's no 6x there. That doesn't work. Or you might think, well, maybe it's difference of squares, even though that's a plus sign. But that would be x squared minus 9. That doesn't work. So it really doesn't factor. So there's nothing called sum of squares. We don't really have a way to factor that, but we do over the real numbers. But we do have only if it's a difference. So be careful about that. That could be a trick question. So when a leading coefficient is not 1, so in this case, you can guess and check this. So here's what I mean. So one way of doing this is to guess and check it. So instead of x and x like we normally do, one of these would have to be 2x, if that makes sense. Because one of them is 2x, I'm not sure. I know one of these is plus and one of these is minus, but I don't know which one goes where. I know it's factors of negative 10 that add up to be 1. So, boy, this is going to be tough. So I'm just going to write out factors of 10. So 2 and 5, 10 and 1. And I don't know which one of these is going to work. I might get it my first try. Whoops. So I'm going to put 2 up there. I'm going to put 5 up there. Okay, so could any combination of, and so I'm kind of looking at inside outside here. Could 2 plus 10 equal 1? And I don't think that's going to work, right? But if I change the order, in this case, because one of these is 2x and one of these is x, I could change the order. And that would be 5 and 4. Well, 5 and 4, that could work here. So now we may be onto something. The bigger number needs to be positive, so plus, and then minus. And I think we've got it. So it can be solved that way. That's called the guess and check method. But there's another method we can use. So let's try the other method. It's a little bit more foolproof. Sometimes it can be a little frustrating to do guess and check. It just takes a while to guess and check it, I guess. So this method is called the AC method. When I say AC, I mean this: ax squared plus bx plus c. So a is 2 and c is negative 10 there. So you multiply a times c. So 2 times negative 10 is negative 20. So step 1 is you do AC. Step 2 is you factor AC as much as possible. Many different ways as possible. So like in this case, it would be 1 and 20. I know one of those is negative. 2 and 10. 3 doesn't go to 24, and 5 goes into 20. I know I'm done because I've already gotten 5 there. That'll be the next number to test. So one of those combinations might work. So what you're looking for here is we want to get, so step 3 is find the factors of the ones you just chose that add to make B. B being like this B term, the coefficient of x there. So which one of those could add up to 1? So 1 and 20 cannot, 2 and 10 add up to 8 or 12, but not 1. This could work. One of them has to be negative. It's a positive one, so I'm going to make the 4 negative. So step 4 is kind of a weird step, but you want to use, use the factors you found. Use the factors you found to split up the middle term. Split up the middle term. So you're going to split up that middle term to be, I guess one of them is going to be negative 4x plus 5x. And your other two terms are pretty much the same here, so 2x squared plus minus 10, sorry, minus 10. So now I have 4 terms to my got to factor these 4 terms. So now at this point, we do something called factoring by grouping, which I hope you've seen before. Again, some of this lesson, factoring by grouping, I think you've done before. So factoring by grouping is when you kind of group the first 2 terms. So factoring by grouping, you want to group, step 1, I guess, is group into 2 groups, which with a plus sign in the middle. You want plus and then two things. So I want it to look kind of like this. So I take whatever the first 2 terms are, put them in the first group, 2x squared minus 45. Take whatever are the next two terms. In this case, the 5 is positive, so it'll be 5x minus 10. Next step for factoring by grouping, step 2, is to pull out GCF of each group. Pull out the GCF of both groups. So you're going to pull out a GCF this way. This will be, this is 4x, by the way, not 45. That's 4x, sorry. Minus 4x. You split that, basically split 1x into negative 4x plus 5x. I don't know why I wrote 45. It's just probably really sloppy writing there. Okay, so 2x squared minus 4x. So the GCF would be 2x times x minus 2 plus, pull out the GCF of that one, that would be 5 times x minus 2. Now, whoops, x minus 2. Now the thing that you might notice, which is kind of cool, is this parentheses matches this parentheses exactly. That's how you know you've been successful at factoring by grouping. So the third step is if the parentheses match, which they do, and so you've only been successful if you can match the parentheses, then you regroup. You basically have factored, you just have to regroup it into factors. So I'm going to have factors now, so this can be multiplied, not, so one of these, I'm essentially taking out the GCF is x minus 2. The other one's whatever's left over here, 2x plus 5. And if you look, I think we got the same answer, 2x plus 5 times x minus 2. We did get the same exact answer, different order, but that doesn't really matter in this case. So that's called the AC method. And I don't care which method you use. You could even use another method if you're comfortable with another method. So try this one. I think we will have some more practice on the next lesson as well. But one way of doing this, again, is to guess and check it. So one of these would be 3x, one of these would be x. You could do 8 and 1. I guess the other one I would need to try is 4 and 2, some combination of that. So let's just try that. So there we go. Okay, 8 and 1. So we want numbers that add up to make negative 10 there. So 8 plus 3, that doesn't work. About this one, but I'm not too optimistic. 24, when you do outside, plus 1, that doesn't work. So I don't think we're going to factor with 8 and 1. Let's try 4 and 2. So 4 and 6. Okay, so that might work, but problem is one of these needs to be positive, one needs to be negative. Those would both have to be negative. I don't like that. I don't think that's going to work. 2 and 12. Okay, so let's double check this. I think this could work here. So when you do inside outside, 2x plus 12x, or 2 and 12x could add up to negative 10. The bigger number would have to be negative. The smaller number would have to be positive. The multiply to make negative 8, 2x plus negative 12x is negative 10x, 3x times x is that. That one definitely works. You can double check it if you want to. Let's also do this by doing guess and, or do the AC methods. Let's do this one more time. See if we can kind of get this down. It's not too bad after you do it a few times here. So AC would be 3 times negative 8, which is negative 24. So you're going to factor negative 24 a bunch of different ways. 1 and 24. I like to be systematic. 2 and 12. 3 and 8. 4 and 6. I know I'm done. Now I just have to pick out the magic factors here. So I have to add up to make negative 10. So that doesn't work. That doesn't work. One of these guys is going to work. One of them's positive. According to the last term, one's positive, one's negative. So if that's true, I think I would make this one negative and this one positive here, and I could do this. So I'm going to split up that middle term to be 2x positive minus 12x. And the other two terms, again, are going to remain the same. So that's going to be 3x squared plus that and minus 8. So now I'm going to group these into two parentheses with a plus sign in between. This I'll call factoring by grouping. The first two terms just go in there, 3x squared plus 2x. This is where it gets tricky. That 12x is actually negative, so I'm going to bring down the negative 12x minus 8. Okay, pull out the GCF, and so that'll just be, well, that's just x times 3x plus 2. Remember, we never want this first term to be negative, so I'm going to pull out a negative and a 4, I believe. So I'm going to pull out negative 4 times 3x. Instead of minus, it's going to be plus 2. I pulled out a negative. And if we're lucky, and we were, the parentheses match, which is excellent. So at this point, you're going to regroup, and you get x minus 4 times 3x plus 2. And that's the same answer we got this way as well. So that's your lesson for today. Just a lot of factoring. And we'll do more factoring tomorrow, I believe, too.